In 4.3, Part 3, we're going to talk about building the unit circle. Now, in 4.3, Part 1 and 2, we used the fact that we kept using this r value. Well, what mathematicians found is if they made the r equal to 1, so they only looked at the sine, the cosine, and the tangent for a circle with radius 1. The sine, the cosine, and the tangent became easier. So instead of dividing by 1 or using that, instead of dividing by r, we could divide by 1. So some really cool things happened. And what happens is on the unit circle, the sine value ends up being, before it was y divided by r. Now, but r is 1, so it just becomes y. Our cosine becomes just x because it was x divided by r, and now it's going to be 1. But our tangent still is y over x. Now, the unit circle clearly gives us sine then cosine because that's just going to be our y and our x. We're going to have to divide those to find our tangent. And then the other three trig functions, cosecant, secant, and cotangent, we're just going to have to flip over whatever we get in order for that to work. Now, it's vitally important that you know how to build this unit circle because you're going to have it memorized. But there's lots and lots of patterns in there. So the first thing I want you to do is I want you to take a minute and I want you to color code your lines like mine are, okay? So my quadrantal angles, my 90, my x and y axis, make that yellow. Make the x that's the widest, closest to the x-axis, make that red. Make the 45s right down the center, that perfect x, green. And then make the widest, the skinniest x, make that blue. So I'm going to give you a second to do that before we get started. Now, let's take a look at the yellow lines. Those are our quadrantals. Now, on this unit circle, there is a line for the degrees and then a line for the radians. So first, what I want to do is I want to put all of my degree measures on for the yellow. So this is going to be 0, 90, 180, 270, and we can also call this 360. Now, let's put on our radian measures. This is 0 radians. This is 90 out of 180, so this is going to be pi over 2. This is going to be pi. This is going to be 3 pi over 2. And then this can also be 2 pi. Now, let's talk about on the unit circle. Now remember, this circle has radius 1. So let's go through the points. So this is going to be, this is going to be 1, 0, 0, 1, negative 1, 0, 0, negative 1. What's really cool is, remember, we just discussed that all the y values now are exactly the sine at that angle measure. All of the x values are the cosine, and then the tangent, we just divide them. So look what we just found. Let's start with the 0 or 360 spot. I know the cosine is 1, the sine is 0. Let's go to the 90 degree spot. The cosine is 0, the sine is 1. Go to the 180 spot. The cosine is my x, negative 1, the sine is my y, 0. So it becomes so useful. Now, let's go and do the same exact thing for the red. So I'm going to focus now on our reds. So I'm talking here. All of our reds have a reference angle of 30 degrees. So we are 30 degrees away from the x-axis. They are all some type of pi over 6, which we'll talk about more in a minute, okay? So first let's put the angle measures on. So we've got 30. If we're 30 above 180, that is 150 over there in the second quadrant. In the third quadrant, that's 210. And in the fourth quadrant, that's 330. Okay, now let's put on our radian measure. Every 30 degrees is a pi over 6. So the way that I think about it, I just remember that. 30 degrees is pi over 6. And what I do is I think how many 30s are in 150? Well, 5. So that has to be 5 pi over 6. How many 30s are in 210? 7. So guess what? That's 7 pi over 6. And then 330. How many 30s are in 330? 11. This is 11 pi over 6. If you forget, or if that is hard for you to calculate, you can always do a really cool trick. You can just tack on a pi and put it over 180 and then reduce it. If you did 150 pi over 180, you're going to get 5 pi over 6. Okay, now let's do the points. At the beginning of chapter 4, I think it was in the Get Ready for the Chapter, we talked about special right triangles. This right triangle here, just focus on that triangle right there. That triangle has a 30-degree angle right there. So the shortest side is right here. And that was always half of the hypotenuse. We know this hypotenuse is 1, so that's a half. And then remember what you did next. You tacked on a square root of 3. So this is square root of 3 over 2. So that special rule gives us that the x value is square root of 3 over 2. The y value is 1/2. Now what's really neat is that triangle lives here, it lives here, and it lives there. So we get 4 of the same values. The only thing that happens is we have a change in sign. In the first quadrant, this is positive, positive. Second quadrant, negative, positive. Third quadrant, negative, negative. Fourth quadrant, positive, negative. So this value that I have written in red is going to repeat here, here, and here. Just change the sign accordingly compared to what quadrant you're in. So this one is going to be negative square root of 3 over 2, 1/2. So the x is negative, the y is positive. This one's going to be negative square root of 3 over 2 and negative 1/2, both negatives. And then this one over here is going to be a positive square root of 3 over 2, but a negative 1/2. Now let's think how cool that is. I know that the x's are the cosine, so I know the cosine of pi over 6, 150, 210. I know the sine, I know the tangent, and if I know those 3, I can flip them over and find the other 3, the cosecant, secant, and cotangent. Okay, so we built the red. Now let's change our color to green. We're going to do the middle green ones. The middle green ones are related to 45 degrees, which is a pi over 4, okay? Remember at the beginning of the chapter, we talked about special right triangles. That is an isosceles right triangle. Both this leg and this leg are exactly the same because that's 45, and so is that. So something neat happens there. If you would do the Pythagorean theorem on that, you get that the legs are both square root of 2 over 2. So what's great about 45 is both the sine is square root of 3 over 2, square root of 2 over 2, and the cosine are square root of 2 over 2. Okay, Now, let's fill in the other information about our green lines. So let's go to the second quadrant. In the second quadrant, we have 45 above 180, that's 135 degrees. If we count how many 45-degree sections that is, that's 1, 2, 3 of them. 45 goes into 135 3 times, so that's 3 pi over 2, or I'm sorry, over 4. And we're still going to use the point square root of 2 over 2, square root of 2 over 2, except now make the x negative. And then if we go in the third quadrant, that's 45 past 180, or 225 degrees. How many pi over 4s or 45-degree sections are in that? 1, 2, 3, 4. There's actually 5 of them. You can count it off that way, or you can divide 45 goes into 225 5 times. So that's 5 pi over 4. Its point's still the square root of 2 over 2's, except now they are both negative. Now let's go in the fourth quadrant. We are 45 away from hitting the 360 mark, so that's 315. 45 goes into 315 7 times, that's 7 pi over 4. If you counted the sections, that's 1, 2, 3, 4, 5, 6, 7. 7 pi over 4s. The point is still square root of 2 over 2, except our x is positive and our y is negative. So those are all our 45s. And then finally, let's do our blue ones right here. Our blue ones, if you drew this triangle, you're just taking the same red triangle we built right here and turning it on its side. It's still a 30, 60, 90 degree triangle. That's 60 degrees. What's really cool, though, is the triangle flipped, so the legs flipped, and so instead of square root of 3 over 2 1/2, it becomes 1/2 square root of 3 over 2 is our point. So I know that the cosine of 1/2 is, or cosine of 60 is 1/2. The sine of 60 is square root of 3 over 2. Now, what is the radian measure? Well, 60 goes into 183 times, so this is pi over 3. The next one in the second quadrant is 120. 60 goes into 122 times. That's 2 pi over 3s. Still going to use the point 1/2 square root of 3 over 2, but make the x negative. So that's negative 1/2, but positive square root of 3 over 2. And now down in the third quadrant, that's 60 past 180, or 240. 60 goes into 244 times, so that's 4 pi over 3. Same 1/2 square root of 3 over 2, but make both of them negatives. And then finally, 60 away from 360 is 300 degrees. 60 goes into 305 times, so this is 5 pi over 3. Same point, but make the x positive, but the y negative. So what's really cool about our unit circle, all of the points that are on here, we know now without a calculator the sine, the cosine, and tangent pretty easily. And they're all related, and they're all multiples of 90, 30, 45, 60. Okay? You are going to have this memorized, just so you know. Now, there's another type of pattern and chart that happens. Now, if we only look in the first quadrant, remember, the sine is our y, the cosine is our x, the tangent is y over x, or sine over cosine. Let's fill in the radians. That's 0 radians, pi over 6, pi over 4, pi over 3, pi over 2. See how this number keeps getting smaller? Okay. This is the cool pattern. If you start at 0 and we only focus on the y's, so just focusing on the y's. Now, we're only looking at the first quadrant. It starts at 0 and ends at 1. But what happens in between? Well, this is really cool. This is the pattern. It's square root of 0 over 2, square root of 1 over 2, square root of 2 over 2, square root of 3 over 2, square root of 4 over 2. Now, obviously, some of that reduces. So this is just 1/2, and this is, the others are fine, okay? But this is what's really neat. The cosine are those same exact values reversed. This is 0, this is 1. So this is square root of 0 over 2, square root of 1 over 2, square root of 2 over 2, square root of 3 over 2, and 1. So this one goes from 0 to 1. This one goes up from 0 to 1. Now let's reverse them. Let's find the tangent. So now we're going to take the y value divided by the x value. So 0 divided by 1 is 0. 1/2 divided by square root of 3 over 2. The 2's end up canceling because they're in the perfect spot. And so it becomes 1 over square root of 3, which is square root of 3 over 3. So like these end up canceling. The next one is going to be square root of 2 over 2 divided by square root of 2 over 2. Anything divided by itself is always 1. So the tangent of 45 is 1. Now let's do the tangent of 60. So that's going to be square root of 3 over 2 over 1/2. The 2's are going to cancel. So we're just left with square root of 3 over 1 or square root of 3. And then finally, the tangent of 90 is going to be 1 divided by 0, which is undefined. Okay? So that's a really cool pattern that also happens. And if you know the first quadrant, so this is quadrant 1, if you know the first quadrant, those patterns continue over and over. Now, these problems here hold off. We're going to do those at a later date. So let's skip those for now. And let's just do these problems here. Now, if you have the ability to open up what we just did above our unit circle and use it as we go through this, that's what we're going to do. I have that unit circle a little bit in my brain, so I'll be able to just kind of draw a little picture for you, okay? So the sine of 4 pi over 3. Pi over 3, you might recall, is 60s. 4 times 60 is 240, so this is really the sine of 240. If we drew that a little picture, 240 is down here. The point there, eventually you'll have memorized, is negative 1/2, negative square root of 3 over 2. The sine is the y value, so the answer is negative square root of 3 over 2. See the importance of memorizing the circle? You know the circle, you know the sine value. Let's do tangent. Tangent of 150. 150 is right here. It's related to your 30-degree triangle, and so that's really negative square root of 3 over 2, 1/2. Excuse me. Now the tangent is the y value divided by the x value. So the tangent of 150 is the y value, 1/2, divided by negative square root of 3 over 2. So we know it's going to be negative. The 2's are going to cancel. We're left with negative 1 over square root of 3. Now that is the answer. Rationalize it. That's negative square root of 3 over 3. Pop that radical to the top and leave a normal 3 behind. 15 pi over 4. 15 pi over 4 is related to our 45 degrees. Pi over 4, anytime you see pi over 4, think 45 degrees. Let's count 15 of them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Oop. So it landed me right there. That right there is the 45 reference, and the point is the x is positive and the y is negative. Now, the secant is the flip of the cosine. Now, this is the cosine. The cosine is the x value. So the secant, just take the x value, which we see right here, flip it upside down. So it's going to become 2 over square root of 2. Now, let's practice rationalizing that. That's going to be 2 square root of 2 over 2, because we pop the square root of 2 to the top, leave a normal 2 behind. The 2's cancel. The answer is square root of 2. So, interesting fact, if you ever need to flip over square root of 2 over 2, it's always just going to be square root of 2. So there you go. That is the secant. Let's look at 5 pi over 6. 5 pi over 6 is 5/30. If you looked on our unit circle, that's 150 degrees. Same point, we can just use the same picture. I guess I used the same thing right here. So we're going to look up there. The point we're using is negative square root of 3 over 2, 1/2. The cosine is just the x value. So the cosine of 5 pi over 6 is negative square root of 3 over 2. Let's keep going. 7 pi over 6, related to 30. 6 goes into 180 30 times. 30 times 7 is 210. It's right here. The point there is negative square root of 3 over 2, negative 1/2. And you can find that from the unit circle, and eventually, hopefully, you can just have it memorized. What's the sign? It's the y value. So the answer is negative 1/2. Let's go to the cosine of pi over 3. Pi over 3 is 60 degrees. The point there is 1/2 square root of 3 over 2. The cosine is the x. The answer is 1/2. See how important it is to memorize your unit circle? It's got all the answers hiding right in it. 4 pi over 3. Pi over 3 is 60. 4 of those is 240. So this is really the tangent of 240. If you draw 240, it's right here. The point is negative 1/2, negative square root of 3 over 2. We're going to take the y value divided by the x value. Now, 2 negatives make a positive, so the tangent is always positive if you get an angle out of the third quadrant. And then the 2's cancel, so it's just going to be square root of 3 divided by 1, which is square root of 3. Let's go to the secant of 270. The point at 270 on the unit circle is negative 1. No, it isn't. Let's go back. It's 0, negative 1. And so the secant is related to the cosine. Now, the cosine of 270 is 0. So if you flip over 0, you get 1 over 0, which is undefined. So anytime you try to flip over 0, just write that null set, that undefined for me. Okay, so there's that. And we just have a few more to go, and then we're done. Let's take a look at this. The cosine of 9 pi over 4. Pi over 4 is our 45s. Let's draw some 45s here. 9 of them. Let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9. Ooh, that lands us at 45. The point there is square root of 2 over 2, square root of 2 over 2. What's the cosine? The answer's right there. The answer is square root of 2 over 2, the x value. Let's do the sine of negative 300. If you add 360, you can see that that lands us in the 60-degree spot. The point there is 1/2 square root of 3 over 2. You can find that from the unit circle. So what's the sign? It's the y value, square root of 3 over 2. It's that value right there. Perfect. 29 pi over 6. It's more than we need. Every 12 pi's over 6's gets me all the way around, because 12 divided by 6 is 2 pi. 2 pi gets me around. And so if I take off 12 pi over 6's, I'm left with 17 pi over 6's. Take off another 12 pi over 6's, and we are left with 5 pi over 6. So that is coterminal, or lands me at 5 pi over 6, the 150-degree mark right here. So finding those coterminals are also very important. It lands me at 150, and that's why we practice that. That point is negative square root of 3 over 2, 1/2. Now remember how the tangent works. We're going to take the y value of 1/2 divided by the x value, negative square root of 3 over 2. The 2's are going to cancel. it's going to be negative 1 over square root of 3, which is a final answer of negative square root of 3 over 3 when rationalized. So there is part C. Negative 495, add 360. Let's get it a little more what we want. Negative 495 plus 360, still negative, negative 135. So let's add another 360, and we get 225. 225 is the 45-degree angle measure down in the third quadrant. That point is negative square root of 2 over 2, negative square root of 2 over 2. So the cotangent, remember tangent is y over x, so cotangent is x over y, so that's negative square root of 2 over 2 divided by negative square root of 2 over 2, which is equal to 1. So that is our cotangent for D. And then finally, the secant of negative pi over 3. Negative pi over 3 is right here. It's the pi over 3 in that quadrant. Pi over 3 is just our 60, so I guess I didn't draw it very good, but it's more like here. The point there is 1/2 negative square root of 3 over 2. Now, the secant is going to flip over our x value, because x is our cosine, so just flip it over. So the secant of negative pi over 3 is the flip of 1/2, which is 2 over 1, or 2. Okay? So that's building and using the unit circle. Super important lesson. You got to have this memorized. It will help guide you in everything we do for the rest of the year. And I didn't put this, so if you want to put that this is the cosine of theta, sine of theta, and that's y over x, or sine over cosine. We can add that to it too. Okay, so really super important. Please get this memorized. Please practice this as much as you possibly can. Thanks so much for watching. Bye.